Welcome to this programming tutorial. In today's tutorial, we're going to look at object-oriented programming. Python is a procedural language, but it does offer functionality to write or create and write objects. To do this, we're going to use something called a class. A class is a blueprint for creating an object. Let's start with an example. We'll create a class for a chair. To do this, I'll call write class and name it chair. Notice it doesn't have the two brackets after it. Inside a class, what we need to do is we need to create a constructor. That means we need to create a method that's able to create each object as we write them in. In Python, to do this, we define it like a subroutine, and we use a special identifier called __init__. Init stands for initialized. And in here, we're going to pass a couple of things. Self, X, Y, Z. Ignore the self for now. We'll go over this in a little bit. So let's create some properties for our object. We'll call it self.number of legs, which is going to equal to my X variable. Self.color, which is going to equal to my Y parameter. And self.softness, which is going to equal my Z parameter. Let's also create a subroutine inside this class called getChairSoftness. And then we're going to return the softness of the chair. Let's now create an object. We'll call it myChair1 and make that equal a new chair that has 4 legs, is red, and has a 10 rating for softness. We'll also create another object, myChair2, which equals a new object with 4 legs, blue, and a 5 level of softness. Now let's go over some of the stuff we've done. First and foremost, what is self? Self represents an instance of the class. By using self, you can access the attributes and methods of the class in Python and apply them to the object, or apply it to itself. You'll notice that it's automatically passed in here. We don't have to specify it inside the brackets. And when I write self.number of legs in the instance of chair1, it'll apply number of legs variable to chair1, which is self. It's an automatic process of passing in the object into whatever subroutine you're using. That's why I have self here as well. Because if I want to get the chair softness of my chair1, I can just write get chair softness with nothing in the brackets. And because I've written self here, the program knows that this object goes into the self. So when I call self.softness, it's as if I'm writing my chair1.softness. By writing .softness, we're going to return the variable of softness. Let's have a look. There we go. 10. Now, classes in Python can also represent public, private, or protected attributes. This is to help with something called encapsulation. To use these access modifiers, we have 2 different ways of doing this. We can specify a variable as being protected by using an underscore, or we can specify a variable as being private by using 2 underscores. Now, this in itself doesn't really do anything because Python doesn't really use private or protected attributes or access modifiers. By default, everything in Python is public. Like with constant variables, in Python what we do is we specify it in our code using underscores and 2 underscores so that other people know that we want those to be protected or we want those to be private. And remember, encapsulation means ensuring that the sensitive data is hidden from users. So this is really important in other languages. Let's remove them now and keep them as public. We also have the idea of inheritance in our classes. Let's switch over to a different type of class. This is a class that defines a person. It defines a person with a name and an address. If I run this program, you'll see I should get Jacob here. Let me introduce you into another concept called inheritance. We've already looked at how to instantiate or create an object. However, what if we want to have a person object where we can have other types of classes that inherit from this class? Let's create another class underneath. We'll call this class students. But unlike previously, we're going to use brackets here because I want to pass in person. We're going to define its own constructor over here. Again, we'll pass in the self. We'll pass in X, Y, and year. And this time, what I'm going to do is I'm going to call the initialize function from the person class, also known as the superclass. And we want to pass in the self, the X, and the Y. I'm also going to create an extra variable for year. We'll call it underscore year. And we'll make that equal year. And let's create a subroutine called getYear, which passes in itself and returns itself's year. Great. Now let's create the students. We'll call the students Chloe from France, and we'll put a year of 11. And instead of outputting person, we're going to output students.getYear. Now, what have we done here? In the initialize function for our student class, we are calling the superclass. It's called a superclass because it's not inheriting from anything. And we're applying the method we've got here, the initialize method of the person class, with the required parameters that it needs, the self, the X, and the Y. This will then create a name and an address for our student class because it's inheriting from the person class. We're also defining its own parameters over here, so you can have your own custom ones. Now we're able to do this because we are inheriting from the person class, as you can see here. Person is a superclass because it doesn't have anything in it. Student is known as a subclass because it's inheriting from the person class. What's great about this is that I can define all of my parameters in one go. Let's get rid of the person line. I can also write student.outputName, and I can actually use the output name subroutine from the person class because that's inherited in my student class. Oh, we got an error here. Can only concatenate string to string. So this is a type error, so rather than using the plus symbol, let's make our lives easier and use a comma. Happens from time to time. There we go. So this is what's called inheritance, because the subclasses are inheriting properties or methods or variables from the person class. Now, classes in other languages can be also known as abstract classes or abstract methods. An abstract class restricts a class that's only accessed through inheritance. In other words, you can only get it or only use it in inherited classes and not outside. Abstract methods can be used in an abstract class and its body is provided by the derived class. But we don't have abstract classes or methods in Python, not unless you import a special library. What we can do, though, is we can do something called overriding. For example, output name at the moment outputs Chloe. Let's define output name inside here. We'll write self again. And this time we're going to return name is plus self.name. If I now run the program again, what you'll find is I get name is Chloe. In other words, this subroutine over here has overridden the inherited method output name. So overriding is a method that is used instead of the original. It overrides the original. Now, Another instance, or another thing that Python doesn't support that other languages do, is static classes. That's when you set up the subroutine so it's only directly accessed through the class. Again, you could use a library to import it and start creating static methods, but for that, we'll leave it for now. We also have this idea of polymorphism. Let's look at an example. For something to be polymorphic, it means that it has very many different forms. For example, if I do A equals 5, B equals 6, and I print 5 plus 6, I should get the output 11. If I do A equals 5 and I do B equals 6, I should get the output 5, 6. So the plus symbol, we can say, is polymorphic. Oops, let me write out the output here. And let me change this to the correct variables. My apologies. There we go. So we can say that the plus symbol here is polymorphic because the plus symbol has many different meanings. It can either concatenate two strings or join two strings, or it can perform an arithmetic operation on two numbers. Classes also have polymorphism as well. As you can see, output name is polymorphic because it can change depending on the subclass if it's redefined or if it's overridden. Classes are useful when you want to have many different objects loaded with many different properties. It makes it very easy to manage. I often relate classes to the game Sims because each sim, while very similar to each other, will have its own unique personality traits or own clothing, etc. Python is a procedural language, so it doesn't usually run with object-oriented programming, but you can do as I've just shown you today. If you wish to use object-oriented programming language, I would recommend using another one like Java or C#, as they are better suited to OOP. Thank you for watching this tutorial. I hope you found it helpful.